In this video, we will be looking at questions 8 through 19 on your semester review. We are still looking at fractions in this review, and this one is a little lengthy as well. Please, if you have any questions, just ask your teacher when you get to class. Let's get started. Number 8. What is 15% of each given restaurant check? Explain how you calculated your answer. Round to the nearest hundredth if necessary. So remember we talked about that if you are given a percent and you have a whole amount, we can multiply those. So I can say 36 times, and we change 15% to a decimal by moving the decimal 2 times, 1, 2. So times 15 hundredths, because that represents the same thing as 15%. So 5 times 6 is 30, carry your 3. 3 times 5 is 15, plus that 3 is 18. Placeholder, 1 times 6 is 6, 1 times 3 is 3. 0, 8 times 6 is 4, or 8 plus 6 is 4. Carry that 1, and then 3 plus 1 is 5. I have 2 numbers behind the decimal place, so there should be 2. So $5.40 would be the correct answer. You would do the same thing for $18.24. You would multiply it by 15 hundredths. So 5 times 4 is 20. Carry that 2. 5 times 2 is 10, with the 2 is 12. Carry that 1. 5 times 8 is 40, plus the 1. Carry the 4. 5 times 1 is 5, plus the 4 is 9. Placeholder, 1 times 4, 1 times 2, 1 times 8, 1 times 1, 0, 6, 3, 8, 9, 8, 7, 2. You have 1, 2, 3, 4. So this number is the one we have to think about rounding to the hundredths place. So here is the hundredths place. So we have to look at the 6 to tell us what to do with the 3, and a 6 tells us to round up, so my final answer would be $2.74. Okay, they want us to order the following numbers from greatest to least. Please make sure when they're asking you to order, you double check if they want it from least to greatest or greatest to least. So greatest to least means they want the biggest number first. So what I'm going to do is I'm going to change these all to percents because I like using percents. So I know that 75 hundredths, I moved my decimal twice, is 75%, and then I already have 40%. 1/5, I can say 1/5 out of 100, that would be times 20. So this would be 20%, 20 out of 100, so there's 20%. A 1 is move that decimal twice, that means that is 100%. 2/3, so 2/3 we can think of dividing by 2 divided by 3. 3 will go in there 6 times, gives me 18, and you'll notice that it'll continue, so that would be 66.6% repeating, and then 5 hundredths would be 5%. So now I have to think, the highest percent I have is 100%, so 1 would come first. Next I have 75%, so that'd be the 75 hundredths. Oh, sorry, no, I skipped one. I skipped the 90% that was already in a percent form. So 90%, and then would be your 75 hundredths. Then after that would be your 2/3, which was the 66 and 6% repeating. Then you have 40%. Then you have the 1/5. And then you have the 5 hundredths. So that is putting them in order from least to greatest. You can change them all to decimals, you can change them all to fractions, whatever is easiest for you to compare. I personally just like changing them to percents to compare them. Number 10 says plot a point to represent each decimal on the number line. So the first thing you need to do before you even think about placing points is figure out what is it counting by. So if I look closely, it's going, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So that means it's counting by tenths. So what you could do is you could actually write underneath that this is 1/10, 2/10, and continue on, so on, which will help you place this. So this 75 hundredths, I know, would have to go between the 7 hundredths and the 8 hundredths. So that would have to be right there. So this would be A. Next, I have B, which is 1 and 4 hundredths. So I have to count, okay, this is 1.1, then 1.2, and then 1.3, and then 1.4 would be right there. So we're going to put our point right there, and we're going to put B above it. Next, you have 6/10, which would be here, C. And then you have 2 and 2/10, so you have to think, okay, so here is, that would be 2 and 1/10, so 2 and 2/10 would be right there, so that's D. And 29 hundredths, so you know that's going to be less, so you have to think that 2, or sorry, not 2, but 2/10 is like 20 hundredths, and 3/10 is like 30 hundredths, so the 29th hundredths needs to go in between those. So here's my 3, so I'm going to put it closer to the 3, so E would need to go right there. And last you have 1 and 55 hundredths, which you should think, okay, 1 and 50 hundredths is the same as 1 and 5/10, and 1 and 60, or 1 and 6/10 is the same as 60 hundredths, so the 1 and 55 hundredths needs to go in between there. So we're going to count. This is 1, 2, 3, 4, 5, 6. So it would go right in between those two. Would have to be F. Remember, this is going to be multiple choice, so they're probably going to ask you which one of these is on the number line or what A represents. So remember, you need to understand how the line is broken up. If it's broken into 4s, it's counting by 4s. If it's broken into 5s, it's counting by 5s. So please make sure you count the spacing between each whole number, for example, 0 and 1 or 1 and 2. Okay, on 11 and 12, they are wanting us to write equivalent fractions. So remember, equivalent fractions are like equivalent ratios. What happens to the bottom of the fraction needs to happen to the top. So you can see that 3 times 4 gives me 12. So I would also have to multiply this by 4, which gives me 8/12. And then to get from 25 to 1, I divide that by 25. So 25, or 50 divided by 25 is a half. So I added 13 because it's under the same thing, it's just on the next page. So you have to think 15 to 45, that's times 3. But you're kind of going backwards here, so you need to think it needs to get smaller, so that's dividing by 3. So this would be 8. So 8/15 is equal to 24/45. Okay, we are looking at 14 through 17. We're going to focus on 14 and 15 first. It says to calculate each quotient, and we know quotient means the answer to a division problem. And it says to simplify your answers and do not leave it in an improper fraction. So earlier we talked about that dividing by a fraction is the same thing as multiplying by its reciprocal. And a great way to remember a reciprocal is that is flipping the fraction. So if it's 7/8, we're flipping it to 8/7. So if and when we multiply fractions, we just multiply straight across. So 3 times 8 is 24, and 5 times 7 is 35. But this cannot be simplified because if you think about the numbers, 5 and 7 are the only things that can go into 35, and 24, 5 and 7, neither of those can go into 24. So 24 and 35 is the final answer for 14. So we're going to do the same thing for 5/9. So we're going to do 5/9 times, and the reciprocal of 1/6 is actually 6, but we're going to write it as 6/1. And then 5 times 6 is 30. And then 9 times 1 is 9. So 9 will go into 30 3 times with 3 left over. So 3 3/9, which can also be simplified to 3 1/3. Okay, now we are looking at 16 and 17. We're still trying to find the quotient, so we're still following the procedure of changing division to multiplication, multiplying by the reciprocal. But both of these have mixed numbers. So to deal with mixed numbers when we're dividing or multiplying, we always want to change them to impropers. So let's real quick review how do we change to impropers. So if I had 1 and 1/4, that means this really represents that I have 4/4 plus 1/4, which gives me the 5/4 of an improper. Another way to think of this is that you do the whole number times the denominator, which is 1, or 1 and 4, so 1 times 4, plus the 1 on top, so 1 times 4 is 4, plus that 1 is 5. So, but anytime you're trying to think of it improper, think about that you are adding a whole amount each time. So that would be 5/4. So really this says 5/7 divided by 5/4. So now that we are going to change, now that we have it as an improper, we're going to change this to multiplication by doing 5/7 times 4/5. So we're multiplying by that reciprocal, which would give me 20/35. And we know that 5 can go into both of these, so this would be 4/7. Okay, next we have to change this 3 3/4 to an improper. So once again, think about it as 4/4, because that's a whole, plus 4/4, plus 4/4, plus 3/4. So that would give me 12, plus that 3 would give me 15. So I have 15/4 divided by 5/6. But once again, we don't want to actually divide. We're going to multiply by the reciprocal, so 15/4 times 6/5, which will give me 90/20, which simplifies down to 9/2, and then make it to a proper fraction. It will go in there 4.5. So I divided by 10 to get this number, in case you're wondering where the 9/2 came from. And then I just saw how many times will 2 go into 9. It'll go in there 4 times with 1 left over. So 18 and 19 are the last two for this video, so let's get these done. Kavayan, I'm not sure how to say it, is making a healthy after-school snack of ants on a log using celery, peanut butter, and raisins. She has 15 celery sticks, and she has already finished putting the peanut butter and raisins on 1/3 of the celery sticks. How many ants on a log she made? So once again, I'd like to talk about visually thinking about this. So if I have 15 celery sticks, so let's make 15 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And divvying this into thirds. So think about 15 into thirds. That means I would have 5 in each section. 1, 2, 3, 4, 5. So here's a third. 1, 2, 3, 4, 5. And there is a third. So if you notice, you have 5 in each section. So she's already made 5. But if you weren't sure what to do, you could also do 15 times 1/3, which would give you 15 over 3, which is what we did. We divided the 15 celery sticks by 3, which gave us 5. Okay, on number 19, all it's wanting you to do is compare your fractions. So there are 2 different methods you can use to compare fractions. You can use benchmark fractions, where you are looking at, is it close to 1, is it close to a half, is it close to 0, or you can find common denominators. And I will use both methods for this one. Okay, so let's start with 8/12. For this one, I'm going to go ahead and make common denominators because 4 will go to 12 easily. So I have 8/12, and if I want to change the 4th to be a 12th, I would multiply by 3. So I would have to multiply the top by 3 as well. So that would be 9/12. So we would know that 9/12 is greater than 8/12, so 3/4 is greater than 8/12. Next we have 5/8 and 6/10. And I can tell that both of them are greater than a half. So these are going to be very close. If I try to find a common denominator, I would think 40. So if I change 5/8 to be out of 40, that would be times 5. So 5 times 5 would be 25. And then to change tens to be out of 40, that would be times 4. So 6 times 4 is 24. And these were really close. So these were the type of problems where I would definitely be using a common denominator because they're very close. For example, 2/3 is close to a whole, and 5/6 is close to a whole as well. But this is an easy change because I can change this to 4/6. So I know that 5/6 is greater. This next one, I can see that 2/4 is a half, and 7/12 is more than a half because half of 12 is 6, and they have 7. So I don't really have to find a common denominator there because I'm using, is it greater than a half or is it less than a half? Next you have 3/8 and 3/12. This time you can actually just compare the denominators because if you have the same cut, which is you have 3, if I have 3 of 8 versus 3 of 12, 3 of 8 is going to be greater because the slices are going to be bigger than if I cut slices into 12ths. Well, this is where I'm going to stop on this video because then it's going to go into decimal operations. I know this one was long. These fraction problems can be explained so many different ways. Take your time with the fractions. You can do this. I know sometimes fractions get a little busy, but take your time and just double check your math.